Okay, the last thing in 3.2 then is Chebyshev's theorem. Okay, and all we're talking about here is the widest possible spread of our data. So the empirical assumes this kind of bell curve, which happens 99% of the time. Chebyshev says, what if it's not a nice bell curve or everything's like spread out as far as possible? You got all these weird high and low scores. What's the most kind of widest spread we could get? And he's come up with a theorem, and basically here's what all you need to know is here's how he came up with it. But so if k is 2 standard deviations, so for one deviation we don't really have much we can really prove, but if k is 2, that means 2 deviations in each direction, then it has to at least contain 1 minus 2 squared, which you don't even need to remember that, which is just 1 or 3/4. So 75% has to lie within 2 deviations, okay? That's the minimum, okay? Now think back to empirical rule, that was like 95% usually fits within 2 deviations each direction. Remember that? Now Chebyshev just says bare minimum, you'll always have guaranteed at least 75% of the data, no matter how weirdly spread out it is, within 2 deviations each direction, okay? And then for 3, 1 minus 1 over 3 squared is 8/9, and then that just means the very minimum. Now, the empirical rule, the general rule, if it's any kind of bell shape at all, it's going to contain 99.7% of the population within 3 deviations plus and minus, okay? Here he's just saying the very minimum. If everything is spread out so it doesn't even look like a bell curve, all these scores are, you know, from everyone on the test someone got 2%, someone got 3%, 5%, like there's just no pattern to the scores at all. You still have to have at the very least 88.9% within plus or minus 3 deviations, okay? That's all he said, and now you don't need to, we're not going to use this very much, okay? This is just kind of a what-if scenario. You need to know it for this section, but we're not going to use this like we are the standard deviation of the empirical rule and calculating standard deviation stuff, but this is a general rule. So, okay, with that said, here's a problem from the book or from your homework. Suppose quiz scores have a mean of 7.5, so I drew that in there, and a standard deviation of 0.4. So what does that mean? That means in each direction, it's moving in increments of 0.4. Okay, one deviation is up 0.4 to 7.9. 2 deviations, and then of course we go in both directions. 2 deviations up to 8.3, down to 6.7. Okay, another jump out to 3 deviations, 8.7, and minus 0.4 down here, 6.3. Okay, so there's my my spread if it's a normal bell curve, and they said here's our deviations. Now instead of empirical rule, let's just use Chebyshev's theorem. What's the minimum percentage of scores that have to land between 6.3 and 8.7? Well, we have to figure out what deviations those are. So 6.3 I've already got here, that's -3 deviations. So the 8.7 is +3 deviations. So we're looking at this second rule of k equals 3, and again they got it from 1 minus 1 over 3 squared is just kind of the formula, but all we need to really remember is within 3 deviations, 8/9 or 88.9% must fall within there. No matter how weird of a spread everything is, 88.9% must land within there. Probably a lot more, closer to 99% usually, but at the very minimum, 88.9% will fall in there, okay? So here I shaded in plus and minus 3 deviations. Chebyshev just says 88.9 is the very minimum that would land in between here, and we could have some other ones spread out, okay? So that's how you do that. Here's the reference from the book, And that's really all there is to it. Okay, good.